Hello, this is simply about networking, and today I'll tell you about benchmarking, performance, and latency. Standards that describing measurements of performance and benchmarking are RFC 2544 for L3 traffic, RFC 2889 for L2 traffic, and RFC 8239 for data centers. In case you have other types of traffic or other type of network or other modes of operation of your devices, you can either look for specific RFC or using those RFC define your test plan and test operations to measure performance and benchmarking in your conditions. In this video, I'll tell you about benchmark and performance measurement, what influences benchmark and performance, what is latency and jitter, where delay appears, and why we need RFC at all. So, in general, operations of our device are related to transmitting traffic from ingress to egress through itself. And the main idea is to transmit this traffic quickly without influencing interpacket gaps or interpacket delays, and without loss or influence on traffic other than required by specific requirements of our network. In other words, we expect to have zero traffic loss or minimal traffic loss, or frames or some interaction or influence on frames that make them unprocessable on the end station. And actually, benchmark and performance supposed to display us which parts, mechanisms, and features of our device working according to meet those expectations or requirements and which are not. One of the measurement important is measurement of filling and lookup of databases that are used by protocols and features on our device. For example, for FDB, as you remember from video about VLANs, we have operation of learning, where we learning information about or from new incoming frames, taking their source mark, taking VLAN and taking port on which we receive this frame, and adding this information into FDB to in future forward traffic to specific station without additional operations and lookups to know behind which port we have this station. And lookup, when we're looking behind which port available station where this frame is destined by destination mark and VLAN. And obviously, the more traffic we send, the more new MAC addresses are in those traffic, and the more full this FDB is eventually, the longer it takes to learn, to process, and to look up in the database. Some databases, for example, like ACL, they don't have learning, but they have lookup and they have huge amount of entries available. And again, depending on how many rules and conditions we have in ICL table, the lookup will take faster or longer. And eventually, when those operations happens, depending on level or depending on actual stream of frames that we are sending through our device, it will be easier for our device to operate with those, or not that easy. For empty table, it will be easier to learn something new. For full table, it will be longer to look up and to find necessary information to process specific frame or to decide where this frame to send and how. And all of those has influence on benchmarking performance of our device. And by the way, obviously or logically, the bigger frames we have, the less load this stream generates on our device, because with the same bit rate we have less frames and less operations of learning and lookup for same actually physical speed in bits, right? So here is our first influencer on benchmarking in performance. This is frame size of stream. How this influences besides frame size and besides number of operations, it has additional influence. It has the bigger frames we have, the less amount of interpacket gaps we have. What is interpacket gap? Mostly you meet information or visual representation of the frame in the similar way, some pictograms flowing into some direction or in both directions or by circle on whatever other trajectory it can, and we have those empty spaces between pictograms that emulating frames. But how you remember from video related to the streams processing, actually when we go in closer to the stream, we should and could imagine this stream as a set of numbers, hexadecimal numbers, in case we need to operate with frames and to take a look on what values those frames have in different fields, to emulate behavior, to configure our device, or to define expected behavior for our device and for this frame. Or we can imagine it as a binary, and this will be then set of zeros and ones. And this specific interpacket gap will be not some empty space between zeros and ones, but set of zeros. In other words, when we have egress port that sends traffic, link, and ingress port that receives traffic, this is rhythmical operation. In other words, every period of time, every tick, every bit, every bit, some bit is sent, and either it will be treated as 0 or 1 on ingress port. When it meaningful information sent, it will be some set of zeros or ones. If this is non-meaningful information, interpacket gaps, this will be just zeros, so it will be lowest level of the signal, and it will be treated by ingress port as zeros. So it cannot be any spaces or empty spaces, silences, or whatever. It's either one of zeros, and the bigger frames we have, the less amount of those empty zeroed spaces, interpacket gaps, the bigger amount of meaningful information device need to transmit inside itself. And besides, so bigger frame has positive influence on performance, like we need to perform less amount of operations of learning or lookup, or so packet related informations, but we need to transmit and operate with much bigger amount of meaningful bits and need to transmit more bits through our device, and this increases load on our device and increases requirements to benchmarking and performance. Then, next influencer, obviously, logically, is configuration. As you remember from video related to the streams processing and many other videos, we can perform single operation on single stage, depending on some values in single field or set of fields, but it means internally device performs single operation every some amount of ticks on single configuration stage. The more operations we need to perform, the bigger configuration we have, the longer our frame travels through our device. And actually time of traveling through our device, that is configuration based, is a latency. Well, eventually it is very hard to measure latency from ingress to egress on our device. It usually measured as egress time difference between time of egress from egress port on some traffic generator and ingress on ingress port on traffic generator. If you use some hardware devices like Ixia or Spirant, and those are ports on the same device of this traffic generator, this device will measure this information, will calculate latency, will perform a lot of actions you're working with. So this is actually measurable latency dependent on configuration. The bigger configuration we have, the longer our frame will pass through stages on our device, the bigger latency will be. And talking about jitter, especially hardware traffic generators, but in real life, we have some interpacket gaps. So system tries to balance frames evenly through the time of transmitting those frames, and we have some same interpacket gaps or pretty similar interpacket gaps between each pair of frames in the same stream, and we expected to have them in the same way on the egress from our device. In real life, this could not happen, and jitter eventually, this is difference, deviation of actual interpacket frames on egress from interpacket gap of egress for the same pair of the packets. And talking about latency and delay, increase of latency, not signaling about something, and delay, not signaling about something. If we have same device, same packet, same everything, but we increased or changed configuration to increase it, the latency will increase, but this is not a delay eventually, right? We cannot say that this is delay because we can't measure how latency is supposed to be changed in this configuration. This is why it is so important when we measuring performance and benchmarking to have compatible modifications. If we measuring the same packet traveling through the device that have different configurations, different version of operational systems, different version of hardware in the same time, or some combinations of them, the latency and delay tells us nothing. Similar to you have some modifications in your network, you have some modifications of amount of devices in your network, or you send in some different traffic. Once you have incompatible modifications, any measurements losing their sense to us. This is why we have RFCs that providing standard operations, configurations, description of traffic, test traffic as well, that makes those measurements compatible, and comparing measurements of same test related to 544, for example, tell us is the delay and latency, good or bad, comparing to something. So everything is comparing to something. And those RFCs allows us to compare parameters of performance and benchmarking on different vendors, because some vendors providing information about what their devices behave during 2544 measurements, 2889 measurements, and so on and so forth. Having same measurements according to same RFCs on our device, we can compare them with those vendors. That's why we need those RFC, and that's why performance and benchmarking are in reality pretty simple. Thank you. Have a great day.